We're back. All right, David, I do have another meeting, so I can only stick on for 5 minutes.
Okay. Yeah. So one thing I wanted to cover from the previous meeting is how we work with JEDEC. We
Oh, wait a minute.
need to,
Oh, Michael's on. Okay, go ahead, sir.
yeah, Michael is here. So the CDX meetings are open to anybody to contribute, to see what we're doing, and to even copy stuff. But the MOU with JEDEC, the way I understand it is, we right, whatever CDX does, it gets published, and then it gets to JEDEC for adoption. So there is a little bit of right with the PDK as an example. We haven't published anything, right? So I can see Michael, how you would like to get stuff into the JEP 30, but we as far as CDX is concerned, we haven't published anything yet. In fact, we haven't even started to work on it. So I'm not sure how this is happening, and specifically what I would like to do is in the future we follow the process that was agreed, right? Michael, you're absolutely free, right? You can come and contribute whatever structure you think is needed. Actually, I would appreciate if you do that, because that would make the work of merging into JEP 30 later a whole lot easier, right? But this did not follow that process.
I'm not sure I agree with what you're saying there, because we did present the stuff to OCP and to JEDEC. It is the JEDEC's decision to put it into into a ballot process. The OCP provides the comments and the feedback and say whether or not they are ready for to close on that specific piece. Now, as I said, all we had agreed on was closing on the format. We did not agree on closing the rules. The rules, so none of the rules are in the release. It's just the format. Now, what we can do is we can revise what and go through another round of presentation here to show you exactly, so that you're not confused with what you think is in scope and what is out of scope. Because what we put into scope for the release of the JEP 30 is very limited. We said all we said was the format is pretty simple.
So in the format, it's really where these types of rules get put into the overall.
It doesn't say what rule gets put into what bucket. It just says that if you put a rule into this bucket, it has to follow this structure. And so we have a number of different structures to accommodate different types of rules. So for example, if you want to take a measurement between two features, then you have to be able to identify the first feature and identify the second feature. And you might want to say the first feature is located in this area and the second feature is located in a different area. So the structure to enable you to do that, that's what we've defined. Putting a trace-to-trace rule into a substrate bucket or into a package assembly bucket, that is yet to be defined. That's the next phase.
Okay.
Okay. Okay. Yeah. So that's fine. The
And
process.
what we also did is we said, let's take a look at what other industries have done. We took the example of what IPC did for creating rules for creating footprints. They have a separate document for that, and they have and so we followed that concept, right? We said one document is going to be used to write the rule because we expect that to change on a frequent basis, but the format of which it applies, that it should be implemented in, from that has to be consumed by software tools, that format should never be changing if possible. It should be remaining static for as long as you can, because you don't want to be making big modifications to software tools that implement them. But the rules themselves, they can change all the time.
Okay. Yeah. What I
Right,
was trying to say.
I'm gonna have to leave, guys. Anything else for me?
Yes, Tony. So on the SIPA stuff, we need help from somebody who actually
Yeah.
does SIPA stuff.
Yep,
Be-
that's gonna be Mohammed, and I want Mohammed involved in that, so.
Okay. Yeah, because there's two components. One is right, the data that needs to be exchanged, but then the workflows that consume that data. I spoke yesterday to the die-to-die group, how they see us providing this information, and they were a little bit confused because there is different workflows. Then there is the definition that goes in IBIS. What do we define outside of IBIS and so on? So we need somebody to help us on that front.
Yeah,
Right.
yeah, we've got a really good SIPI guy, Mohammed Hassan. So I want him as part of that group.
Okay. Okay, so it's just a few of us. We need him for the next meeting then, in 2 weeks.
I am out the next 2 weeks, so maybe the week after.
Okay, can he join?
Yeah.
Okay, yeah, basically not next week, the week after. Where we can start hashing out the parameters that need to go into the CDXML.
Okay, sure.
Okay.
Yeah, we might want to just set up a short call with you, me and him, maybe just right after our call today. He'll be on the call that we're doing later.
Okay, I'm booked. It will have to be much later today. If it's today, it'll have to be much later.
Okay, that's fine.
Okay.
You'll meet him on the call, and we'll just do a quick intro, and feel free just to set up a call directly with him.
Okay. All right.
Okay, bye guys.
All right. Hello, Jeff.
Hi.
I need to go.
We're gonna have so Jeff, we're gonna have a short meeting today. We'll probably do a little bit more next week. Because we were just finished discussing from another meeting.
Before I leave, Jeff, what is your expertise? This is Tony Master, and I'm from Siemens. I'm responsible for our 3DIC roadmap.
Yeah, so Jeff McGuire from Ventana Microsystems. I'm just re-engaging in OCP work efforts to kind of understand what's going on in terms of the chiplet ecosystem.
Okay.
So I'm just starting to survey a bunch of different calls. I am the director of product management at Ventana. We develop high-end RISC-V CPUs, and then we also have a bunch of system IP for RISC-V to pull together solutions, and we've been pretty active in the BOW efforts. But we're kind of moving down in the direction of UCIe going forward.
Yeah. Okay, so Jeff, maybe you can also help us out. One of the things we are working on is a SIPI kit, basically a
Take care, guys. Nice meeting you, Jeff.
Yeah, nice meeting
All
you,
right,
Tony.
Tony. All right, Tony. Talk to you later. So Jeff, one thing that so the way we do at CDX is we usually have different topics that we tackle, and we alternate every other week. This week is a SIPI topic. What we are trying to do is develop our overall charter is to digitize any data sheets, right, and to enable workflows. Right, we don't want PDF files floating around and being read by people and then numbers being punched in. Right, we want to enable workflows that will scale the design with chiplets. So the SIPI kit, the way the intent of that is to focus on describing the parameters for die-to-die interfaces, such that SIPI engineer, when they start planning for the system or start simulations, start exploration, they get some of those parameters from a file, and they can load into the analysis tools. So can somebody from your company help us out, somebody with SIPI expertise who's been running these things, to help us out, refine our definition, what we have captured so far, and refine it in a way that would be useful for your company?
I mean, I'd be happy to review what you have. I don't know if we have particular expertise in this area.
Okay.
And I don't know if it's specific to 3D IC. It's something we've looked at, but we're more focused on like 2.5D type
Yeah,
at this point.
yeah, I'm guessing it's the focus is going to be mostly on 2.5D die-to-die interfaces. For 3D, we are not there yet. It's not entirely clear, right? And at least it should be a lot simpler, right? Because you have just the 3D connection, and that's about it, versus package routed, right, cross substrate with losses and all that weird stuff, right? So what? Let me briefly flash what we have been collecting. Give me 1 second. I need to.
Okay, and maybe just I'll give you one more bit of clarity on kind of our focus is we have a very low latency controller, chiplet controller, where we take AMBA protocols and we packetize them. And we it used to be interfaced to a BOW PHY. Now we've got it interfaced to a UCIe FDI layer. And so that's really kind of our focus, and we can leverage any UCIe PHY vendor that way. So in terms of all this connectivity, I don't know if it's more focused on the PHY vendor side of things or what we're working on.
So the idea is you will have when you have a chiplet with a PHY on it, it will hopefully first of all, what we would like to do is describe which pins of the chiplet are which PHY protocol, right? We can say, hey, these 18 are BO, or these however many are UCE. Here's the data pins, here's the clock pins, right? So that they're fully mapped, right? We know not only, right, the bump map of the chiplet, but we know in a digital format that these so many bumps and pins are UCE, and that UCE needs to connect to another UCE on the other side. right?
Okay.
So,
Yeah.
so that's the first order. The second order is, excuse me,
Mhm.
the the you see, or Ball would define a electrical parameters, right? That typically, if you want to run SI, you would open the standard, read read the entire specification, however many hundreds of pages are, extract what you need, and populate those values in your simulation tools and in your simulation uh, environment, such that it drives the simulation on one side, and on the other side, it checks if the simulation has passed or not. Right. So, for example, simple one, right? You don't have to go and read 200-page document to find out what is the requirement for the I diagram on on the receiving side.
Yeah.
That can come from from the file, and the tools will load it and will automatically check and tell you if it's passing or not. Right.
Yep.
So that kind of level description we want to add to a file, that when you give your chiplet to your customer, you say, hey, here's my description of what the pins are and what the electricals are, and they can take that description and put it into their simulation environment. Right. Apart from the standard protocol, standard definitions for the given PHY, I do see cases where the PHY may be better, right? And you would like to understand what that margin is, and basically to enable the vendor of a chiplet to say, hey, my swing is actually slightly better, or my clock jitter is better than what's in the standard requirement, right? Which it would be useful for a customer to understand that it's better, so they can when they do their design, they can see that margin and and understand how much margin they have, right? A couple of hypothetical cases, but that's our overall objective, is to digitize the SIPI portion of the standard or the file description, and then enable those automated SIPI flows. The let me share briefly a document. This is very raw document that we basically this is very raw. We've just captured at a very kind of as a zero order what parameters are there that we need to think about. Right, we were talking about the direction, the what kind of encoding it is, what kind of clock rates, how much is the clock timing mismatch, right? Both on the receiver and driver side, and both in terms of standard definition and particular PHY, right? What is your PHY actually capable of? I diagram limits, data such as data to clock skews, bit skew if there's any requirements, word and byte data skew. I know some memories have that, different requirements for word versus data. Slew rates, what slew rate should be chosen, any impedances, and then stuff like this. So this is the help we are looking for. Basically, to refine these. Some may be dropped from this list, some may be added, but refine this list to a level that is useful.
Okay. Yeah, it seems like you're probably looking for input from 5 vendors at this point. We would be interested in it from a standpoint of supporting it for a chiplet that we put in the marketplace, I think, right?
Yeah.
Yeah. But yeah,
Okay.
if it's if you can kind of point me to it, I can have some folks look at it from our side. See if we have any input.
I posted a link in the chat
Okay.
to this document.
Mhm.
I think it's well readable. So, let me know if you can open it.
Yeah, I can. I see it.
Okay. Yeah. Okay. Again, this is very raw. Right. This is work in progress, so it's not pretty in any way, but kind of
Yeah,
gives the.
don't worry about that.
Okay.
That doesn't
Yeah.
bother us.
Okay.
Yeah.
So
Yeah.
David, go ahead. Sorry, Nishita.
Yeah. If they definitely would appreciate any help with that part.
Okay.
Right. And actually, one thing I wanted to add, for example, on the PI side, typically what I've seen vendors would say, "Hey, here's my chiplet. It needs this much capacitance outside, right? This much additional capacitance on the outside with this much impedance, or this much loop inductance."
Mhm.
I don't know if you specify something like this for your chiplets when you give it to a vendor, but that's very useful information to be able to, especially when planning, right? To understand how much cap do I need, where do I need to place it, and stuff like that. So we're looking to digitize that as well. Vikas, you had a question?
Yeah, so I had a quick question. I think you kind of tangentially touched it. Because suppose we are using an interposers or something, it will bring more cap or so chiplet vendors are going to actually account for that. That this is because obviously the termination resistance and all that will increase after we put interposer and RDL, right? It might vary depending upon the other chip connection. So how are we going to take care of that part?
So I'm assuming we're talking about the die-to-die signaling.
Yeah.
So there are different ways how this is accounted for. In the case of UCAE, the specification itself describes what should be the channel performance in terms of insertion loss and return loss. In the case of a ball, it does not necessarily tell you what the channel should do. It gives you how much basically a budget you have on the RX side and the TX side for SI margins, right? Jitter, skews, and things like that. And then from that, you can work backwards, figure out what your channel margin is, and figure out what your channel needs to do, right? And then you figure out whether the insertion losses and return losses in that particular case are sufficient without giving you the exact values you need to follow.
Okay. So if like, okay. All
Right.
right. That those parameters. So it's like those parameters we will get from the substrate or interposer, right? Like we
Correct.
extract, we got it, we put it
Yes,
back, for the chiplet and see if it is meeting the margins or not.
correct.
Okay. Yeah, that is something that, like you have to really simulate it and see. Like
Yes.
just the interconnect part and all.
That part you have to do some level of simulation to understand what you're dealing with, and then you can construct your topology, routing topology, and so on.
Yeah. That's a good DOE
Yeah.
to do. For us, I mean for time.
Yes. Yep.
Okay, that's all I have.
Okay. I think that's all for today. We'll meet again next week. Next week, I think we'll close on the test design kit, and the week after that we're gonna talk SIPI again.
Okay.
All right. Talk to you
So
later.
test design kit is going to be next week, right? TDK?
Yes. Yes.
Okay, perfect. All right. And are you only running that, David? You will be running that TDK as well?
Yes.
Okay, all right.
Yeah, so
Yeah.
what happened was CDX was one meeting, but then there were so many things that came up at the same time, and right, MDK, ADK, TDK, SIPI, and actually there was another one that we published. So what we decided to do at that time is to spin off a second CDX meeting just for that work. I think we want to continue. We want to at some point merge all. At some point, I mean pretty soon, merge both meetings back to one meeting where we do work. If we need to spin up another one for anything that needs immediate, or if the work is too much, we can always do that. But the intent is to get down to one meeting.
Okay, and when is that one? I don't remember.
That's every
Tomorrow?
every Thursday at 10 a.m.
Oh, that one, yeah, that one I attend.
It's basically this. We're gonna merge it back into this meeting.
Okay, I got it. Okay, and then tomorrow it is demo meeting, which sometimes happens, sometimes doesn't.
Yes.
I don't know. Yeah, that actually I haven't really attended. Whenever I attended, there was no one. So
yeah, over the holidays we didn't
Yeah.
make much progress.
Okay.
Tomorrow we'll have one.
Okay, perfect. All right. Okay.
Okay.
Thank you.
Yep. Thanks.
Bye.
Bye.